Okay, the second non-hydrocarbon gas is hydrogen sulfides. Okay, it is actually a deadliest gas and was produced in large quantities in nature. If you find 0.1% concentrations that apa, eliminates in the air, right, it can actually cause a respiratory paralysis and fatal. So the origins of these hydrogen sulfides gas is actually come from the three main source. First is by thermal decomposition of sulfur oils deeper than the oil window. Okay, and then we have the thermochemical sulfate reductions, right, in the pore waters, right, that accompanied by the oxidation of reservoir hydrocarbons. So it's actually mainly occur in the rock types we call as evaporites. Okay, and then we do have also thermal degradations of the corrosions and coal itself. And then the other three non-hydrocarbon gas that is actually part of the petroleum's product, okay, is come from the nitrogen gas, hydrogen gas, and helium gas. So these three main non-hydrocarbon gas is actually formed independently in petroleum, right? Thus, it can be the indicator of field migrations pathway in the subsurface. So the origins of the heliums came from mantle origins, right? While the helium 4 came from the radioactive elements in this Earth's sedimentary rock. Meanwhile, for the origins of the nitrogen gas is actually came from the oxidations of ammonia in the pore water in the sedimentary rock, in which the ammonia comes from the maturations of organic matter in coals. Okay, and then nitrogen gas also come from the atmosphere as well as the mantle of gassing. Alright, so this is the summary of the origins of natural gas. So this illustrated diagram show the hydrocarbon depth distribution pattern that is repeatedly in many sedimentary basins throughout the world, in which dry gas is actually has been found near to the surface in the immature fascies, okay, during that evolved during the diagenesis process, followed the wet gas, right, in the oil window of the matured fascies, with the temperature uh, occur during temperature within 80 to 150 degrees centigrade. Okay, and then dry gas thermogenic methane, it's occur or produce below in the post-mature phases of the oil window between 150 to 200 degree centigrade, right? So in similarity, the heavier gaseous hydrocarbons is actually formed through approximately the same temperature and depth interval as the liquid hydrocarbons. Okay, deeper than the bacteria methane, right? But shallower than the maximum formations of thermogenic methane. So to be specific, okay, within this range, right? To be specific, okay, from this hydrocarbon depth distribution pattern, okay, the immature fascies, right, that favor with the digestive process usually contains carcinogen with spore and pollen particles in light yellow color, indicating that the organic matter has never been thermally altered. So the dominant gases are actually bacteria methane and nitrogen gases. Okay. In the deeper fascies, right, in the matured fascies, that actually equivalent to the catalysis stage, right, usually contain spore and pollen that ranging from amber to dark brown in color, that indicating the increasing in temperature is actually helping in cooking the corrosions in the sedimentary rocks. So wet gas and oil mainly occupy in the upper part, okay, of this range, right? Meanwhile, the thermal condensate in the lower part with the carbon dioxide distributed throughout this phase. Okay. Near to the end of the catagenesis and the beginning of the metagenesis is the post-mature phase. Usually, if you take samples, right, sedimentary rock from this area, and you conduct palynology studies, right, you will determine that pores and pollen in the kerogen itself is actually going from dark brown to black in color, indicating that the cooking process has eliminated most of the heavier hydrocarbon and formed a zones of dominance in thermogenic methane gas or thermogenic dry gas. Okay, and as we go more deeper, right? Okay, hydrogen sulfide will be increased. The productions of hydrogen sulfide will be increased, and hydrogen sulfide also only found in the deepest and highest temperature regime and serve as the deepest among the natural gas component. So there will be also increasing in the carbon dioxide concentration as well by the inorganic process in metamorphism stage at temperature beyond 250 degrees centigrade. Okay, that's all for the origins of natural gas.